Example 1, we have the function fx equals to 2 times e power of minus x minus 3. And now let us try to sketch this graph here using the simple step in graphing. Step 1, the type of function. So the type of function that we want basically is that, again, we want the base number here for the exponent here terms to be greater than 1. Exponent e, the e is greater than 1. Then we would like to have the power here come with linear expressions. So minus 1 is a linear expression. The rest of the part come with constant. And if let's say we want to compare in details on each of the capital A, small letter a, m, c, and k with our equations here, these are the corresponding result in details. Next, let us go on further with the step number 2 here, where we would like to see what is the shape of graph that we have for these functions here. Step 2, the shape of the graph. So to get the shape of the graph here, what we're going to do is that we're going to identify the sign on two positions. First, we would like to identify the sign on the x, or the coefficient of x. So in this case here, we have negative coefficients on x. The other one is that we would like to see what is the sign on the function. So in this case here, we find out that the sign here is positive, as the coefficient on the function e, the function exponent here, is come with the value of 2 for the coefficient, positive 2. So I have positive coefficients for the case of the base number is greater than 1. So based on this info here, we're going to determine the shape of graph. First of all, we come back to the basic graph, where this form of graph that we have is the case of when the time I have positive x, positive on the exponential function with the base number here is greater than 1. If let's say now I want to have the case in this example here to have negative x and positive on the functions for the a greater than 1, what will happen is that from positive x we want to turn into negative x. Therefore, I need to have the graph flip horizontally. So as a result, this is what we have for the graph that we want from these examples here. This is the shape that we're going to have. Next, step number 3, we're going to determine what is the special line here. So according to the graph shape that we determined just now is this one. So the special line will be this red dotted line here, which is the horizontal asymptote. How we get the answer? Basically, we just refer to the equation here for the negative 3 here, make it equals to y, then that is our horizontal asymptote. Before we go on for step number 4, let us have a quick look where how we can determine the domain and range when the time we reach up to third step here for the case of exponential functions. So first, we want to check for the case of domain. Domain is when the time the graph is extend, how far to the left and how far to the right the graph can go. From here, we can see that the domain, the graph can extend to the left as far as to negative infinity. And in between them, for the other side of the extension, there's no broken parts. So the graph is all the way continuous and then extend to the right all the way to positive infinity. Whereas for the case of range, we want to see how high and how low the graph can go. So on this side here, when the time the graph is extend, when the time we have this perspective of looking upwards, we find out that the graph have the tendency to increase infinitely to positive infinity. And then for the other side, this graph here is getting lower and lower and closer to asymptote. However, it never touched the asymptote. So this indicates that the graph can go as low as negative 3, but never ever equal to it. So this is how we get the domain and range reach until third step here. Okay. Continue. Step 4. To decide the y and x intercept for this graph here, how we're going to do is that make use of the information from the first 3 steps just now. We do a rough sketch. So this is what I have from the result, where I use the special line as a guideline. I draw the graph. I find out that somehow I can see that the graph have the chances to cut the x and y axis in this rough sketch here. So therefore, I can know that there should have x and y intercept axis. However, this may not be the exact point where our graph cut the y and x-axis. So that's why we need to have calculations to further verify the locations in this step here. Therefore, now we continue. We find our y and x-intercept exist. So calculation are needed to verify their locations. Therefore, for y-intercept, we will have when x equals to 0. So we find out that our answer here, we have fx equals to -1, which is the y-intercept. On the other hand, when the time I want to calculate x-intercept, I will take the function fx equal to 0, and by the result from calculator, I find out that I can solve and get the answer negative 0.405, correct to 3 decimal places as a result for the x-intercept. Lastly, step 5. After we have all the first 4 steps done, we identify the xy intercept, we identify the special line, and also the shape of the graph. Therefore, we can have the graph shape as follow, sketch as follow. And in your graph here, please always remember to label the xy axis, the origin, name the graph, the xy intercept if they exist, and at last also the horizontal as in top.